So then, hi, good afternoon. Welcome to my inaugural lecture here at Heidelberg University. So I'm going to talk about software engineering and AI, and maybe taking a slightly more critical stance than some colleagues in software engineering, but I guess also many people in the software engineering industry. But honestly, that's one of the reasons, so being able to do that, that I've moved back from industry to academia, because maybe not all of you know that, but I worked for 3.5 years in the software industry. I always kept ties with academia. So I was in Australia, I was a lecturer there, and then basically I got stuck in Germany due to the pandemic, had to find something new, and then basically I joined a company and then later on moved to a different company, SAP. But I always kept an adjunct position in Adelaide, and I'm actually still adjunct professor in Adelaide. But then at some point I started looking again for academic positions, and a bit by coincidence I ended up at the University of Bayreuth, and I'm very happy that since last year I'm now in Heidelberg. And yeah, that's maybe a bit of a background. So I'm trying to find exactly that balance between research that can be applied in practice, but also that has a certain scientific standard and also distance to industry. And you might see that during the talk, that's something I value. And I have basically 4 messages that I try to convey, and I'd be very happy if in the end of the talk you basically get what I mean with all these points. So first of all, if people hear software engineering, they immediately think programming, but it's actually only a tiny part of software engineering. So that's the first message I try to convey, that software engineering is more than just programming. And there's a lot of discussions about AI, quote unquote, solving programming. And even if that's true, it doesn't imply that AI solves software engineering. So that's the second message that I would like to convey. The third one is that agentic AI and why it works so well in software development is also a model innovation, but it's also a huge systems innovation, software systems innovation. I'm going to talk about that a bit. And then finally, because I'm doing empirical software engineering, that there's still so much need for more solid empirical evidence about AI and software engineering. And my students know that slide because I use it also in other contexts. And to me, still the whole discourse about AI, so I'm talking about software engineering, but I guess it applies to other domains as well, is that people look for these simple solutions or simple answers in the sense of if you use AI, you are X% more productive. But usually it's not as easy as that. If you consider time, for example, doing something over time, then basically being fast now might hurt you in the long run. And that's more the complex discussion to have. But it's unfortunately not that many people that take that route and think about the complex solutions to a problem and that look for the easy answers, but that are usually wrong. Speaking of which, who knows this man? Just raise your hands. Who knows him? Does anybody know him? If I now reveal the slide, you might. Alex knows, okay. But yeah, it's Boris Czerny, and he's basically the creator of Claude Code. I guess even the part of the audience that are not in software engineering have heard about that tool, and he's the creator of that tool. He works for Anthropic. And he has said coding is solved. He has said it multiple times. I linked one of the YouTube videos there where he says that. Yeah, that's a statement. Coding is solved, whatever that means in the details. But then if you use Claude Code, who uses Claude Code and has seen this? Yes, yeah, it's quite a few. They have regular outages, and sure, part of it is load, but then again, load management is a core thing you do in software engineering. And I mean, even the model replies with environment hiccups like this usually clear quickly. I mean, okay. And there's actually data. If you look at Claude status, and there's actually also a community-maintained website, it's linked here, that collects the outages. And then it might sound great. They have 99.1% uptime. But if you look at the colors, maybe it's not so great. And if you do the math, what that means, it's basically about 13 minutes per day they are not available. And of course, it's not like uniformly distributed. Sometimes there's a longer outage, sometimes there's a shorter outage. But I mean, that's not great, even though maybe 99% sounds great. And actually, maybe he saw my slides somehow earlier. Yesterday, he posted, yeah, well, coding is just one part of engineering. Everything else is not yet solved. So, but that's not what he usually says in the interviews, right? He claims that basically software development is solved, but then, yeah, sometimes he admits that's maybe not as easy as that. And that's also well documented in the public discourse that it's not as easy as that. Like there's reports about startups where an AI agent deleted the production database. And then also if it does that, it's usually very good at excusing and apologizing for, oh, sorry, I deleted the data, but nothing we can do now. And there's also like data leakages, privacy issues, security issues of basically vibe-coded applications that end up on the internet. And then, very interestingly, now also Uber's COO, and I mean Uber is one of the leading tech companies in the US, says that maybe, so it's getting more and more difficult to justify token maxing as a goal, which just means telling the developers use as many tokens, burn as many AI tokens as you can, and that's a metric like to achieve, like a goal to achieve, and they start now questioning whether that's actually something you should ask your developers to do. So slowly the discourse is getting a bit more reflected, let's say, than just everything is solved and all is great and it will just get better over time. So I'm talking here about software engineering, software development, and just very quickly the tools that we use. I mean, ChatGPT is a tool, but it's maybe not a tool that is tailored for software development. Like if you do software development with Gen AI, basically GitHub Copilot was one of the first tools that gained adoption, but actually Copilot is older than the LLM hype. Copilot was around in 2021 already, and it was basically a fancy auto-completion in the beginning. And then they started adding a conversational interface where you can chat about your code, have embeddings in your editor where you can quite easily copy and paste code and let it explain things and so on. And then after that, basically, Gen AI-centric IDE started. Cursor, for example, it's a fork of VS Code, essentially, that does things a bit differently to basically build the editor around Gen AI. And then the last bigger innovation were agentic AI assistants. And the difference is you use them in a terminal, and they can call bash tools, for example, and they have a bit more autonomy. Like it's not like conversational back and forth. It's basically the tool can decide, so the agentic tool can decide to call other tools like reading files, searching on the internet and all that. So, and that gave the tool a lot more autonomy, and also it enabled basically writing a whole project from scratch without much intervention. So that was the last bigger innovation in that space. But since this talk is basically tailored for a broader audience, I also wanted to quickly talk about what is software engineering. And also, maybe what it isn't. And with that, I want to ask another question. Who knows this man? One or the other might know. So, do you know who is it? Yes, exactly. And he is the co-founder, one of the co-founders of OpenAI, actually. Then he was for a long time at Tesla, and now he joined Anthropic. And he is the person behind the term vibe coding. So it's actually a tweet or an X post or however you call that nowadays that he posted in February 2025. And I'll just quote a few parts of that. There's a new kind of coding I call vibe coding, where you forget that the code even exists. I just see stuff, say stuff, run stuff, and copy and paste stuff, and it mostly works. And then, of course, there's also a meme that, in my opinion, quite nicely summarizes the spirit of I don't care about the code. I prompt a bit, and then somehow it works, and well, that's fine. So that's vibe coding. He coined that term. And it actually works great in small projects, and I can show you a few examples. Like a couple of weeks back, I needed to register a new license plate and for a car, and then actually the city had like this nice interface where you can check whether a certain license plate is available, but it's also a lot of trial and error. And I had certain things in mind I wanted to check, and I basically asked Claude Code to vibe code an application that just tests patterns step by step, and then like after a few hours tells me these license plates are still available, these are taken along the patterns you defined. And it was not as easy as just calling an API backend, so it was more complex than that. So it was not something I would have done in an hour or so. It was a bit more complex than that, but Claude Code, like with Claude Code, it was half an hour. And I had that tool, I did that, and I knew what I could choose, and then I went on from there. And that's vibe coded, basically. I didn't really care about the code in the end. Other examples, I build tools like to clean up my calendar, to deduplicate inboxes, to download reviews from a platform that didn't have a nice export function for paper reviews and all that. I mean, that's all great projects, it worked great, it served the purpose, I didn't really care about the code. But what I didn't do is I didn't publish, deploy applications to the open, to the internet, because I had a tool that was local, that served a specific purpose, and I didn't care about the code. That's something else from I vibe code something, put it out on the internet, and suddenly my corporate data is leaked. And I hope you see the difference in the two. And vibe coding works great for one, and maybe not so great for the other category, because if you're ignorant basically about what is happening under the hood, stuff like that happens. And then when like the whole vibe coding hype started, there was also discussions on the internet, developers discussing like what is vibe coding, how do you do it at FANG? And for those who don't know the term, it's basically big tech in the US. It's basically an acronym used for them. And then there were the discussions, and then somebody, presumably working for one of these companies, said, well, when we do vibe coding at company X, we start with a technical design document, then a design review before we start implementation. And then if you pass the review, you need more documentation on the subsystems. Then we do backlog development, sprint planning, and then we use test-driven development to implement the features. And then, of course, we also do code review before anything ships, and there has to be 2 humans approving the change before it goes out in production. And then it also doesn't go out in production, but we test it in staging, and then we deploy it to production. And then one commented, and that was the same thought I had, well, it's nice how that implies that the best way to vibe code is not vibe code at all, because that is software engineering, or a form of doing software engineering, a systematic process, because you care about quality, about traceability, about documentation, but that's not vibe coding. And both can coexist. I mean, both are fine, both serve their purpose, but vibe coding is just not software engineering. And I saw this meme, a colleague sent it to me, and I think it still summarizes the idea pretty well. So if you say vibe coding is something you should do for all software projects, then you also believe that like 90% of the software development lifecycle you can just ignore, and it's just not needed. And since SDLC, or the software development lifecycle, is something you hear often in software engineering, I wanted to quickly talk about that as well. So what is the software development lifecycle? Like, it's more or less what you just saw, these different stages you go through until you implement code, test code, deploy code. And I want to do a very brief history lesson there. Who knows this woman? So not only have men on the slides. I mean, some of you are in the lecture, so you should know. Who is it? Yes, exactly. She was, I mean, it's a bit unclear who used it first, but she was one of the persons actually who used the term first. You're absolutely right. It's Margaret Hamilton. She led the software development actually of the space missions, of the NASA missions, the Apollo missions to the moon. And she used software engineering basically to argue, hey, software engineering is as important as hardware engineering. That's how the term started, and she was one of the first to use it. And there's different origin stories of software engineering. I won't go into the details, but she was certainly one of the first to use the term. And then the conference that you mentioned, then it was basically established. The NATO organized, end of the 60s, a conference on software engineering and used the term software engineering, and this is when it was established, basically. So it originates from the 60s. And why did that conference happen? There was a so-called software crisis. So people were used to projects failing because of hardware issues in the hardware design and building the hardware, but now suddenly projects failed due to software and not hardware. And software was often inefficient, or the projects just, as I mentioned, failed because of software. And the software was never delivered. And then they realized that as a problem, and basically it was a call to action. Now we somehow figured out how to build the hardware. Let's talk about software. So that's where it comes from. And then in that report of that conference, you see already like indications of the software development lifecycle, the different stages you go through. You design a system, you think about the requirements, and then you implement, you test, deploy, and all that. That was already there back then in that report. I mean, it's very close to how they were building hardware, and they tried to convert that to software development, but actually it's not that different from how it works today. And the point is, even back then, like programming the implementation was only a tiny piece of a bigger picture. And they even talked about programmers, as they said, not only doing the implementation, but also thinking about design, operations, maintenance. And then years later, the term DevOps emerged as like a developer who also thinks about deployment and the bigger picture. And back then it was already there in the 60s. So. And then you see blog posts like this. It's just a random blog post, a random diagram I selected. So then people call it now top-down vibe coding. And if you look at the things that happen there, you could also say it's just software engineering, but of course we need new fancy terms for, and basically people who are not from software engineering reinventing software engineering and thinking how innovative that is now to do top-down vibe coding. It's just one random example. You find more on the internet. Okay, before I continue, this is basically the definition that I'm using in the lectures. I won't go into the details, but there are some things that stand out, like it's the systematic application of scientific and technological knowledge, methods, and experience to design, implement, test, etc. software. And that's an important part, there was always a particular focus on automation. So Gen AI is not at odds with software engineering, so it was always very open to automating tedious tasks. Automating test case generation, for example, was there before Gen AI started. But the point is, it's a systematic process. You think about what do we know from science, from experience, from technological knowledge, and then apply these structured methods. So that's what software engineering is. And so basically it's the opposite of vibe coding and not caring about the process or the code or anything. So that's basically the first message, that software engineering was never about coding. It's part of it, but there's a bigger picture. And I hope that this is enough to convince you that the first two statements are true, that software engineering is just broader than programming, and it also that implies basically that if AI somehow solves programming, it still doesn't solve software engineering as a whole. And yeah, there was a nice paper also a couple of days ago by Microsoft Research about myths on software engineering and Gen AI. And the first one they describe is developers spend most of their time writing code. And then basically they have a section where they point to related work, but also studies they did at Microsoft. In their case, they said like 14% of the development time goes into, like of the work time of a developer goes into programming or coding. Some studies say 20%, some 25%, but the point is it's not the majority. And they try to basically bust these myths also, because then it's easy if you think like coding is solved and coding equates software engineering, then it's pretty easy to come to the conclusion here that software engineering is solved, which isn't. And on the other side of the spectrum, it's not directly about Gen AI, but it's a good example. Companies like McKinsey, they target C-level management in big corporations. They try to have bold messages out there and that they know stuff. And for example, before Gen AI, even McKinsey said, yes, you can measure software developer productivity. And this, of course, is now even more important with Gen AI because companies want to know how much more productive are developers now. So this is a very important topic. But basically, sorry, I have to be very blunt here. If the one study, the research is Mythbusters, then they're just producing bullshit. That's what they do as a profession. Not all of them, but in that case, it's just look at the discourse on the internet. And what bothers me as an academic is that even before that, there were like tons of papers and even a Dachstuhl seminar that led to a book about software development productivity. And it was academics, it was people from Microsoft, from Google, who discussed productivity, how difficult it is to pinpoint it with metrics, how complex it is. And basically then like a consulting firm goes out there and just says, yeah, sure, we can do that. Like an easy solution, again, a simple solution to a complex problem. And then basically what happens is then people go for the easy solution, and despite the evidence that is out there. And this happens constantly. And I, at least because it's an inaugural lecture, so I'm here also to tell you how I approach things. And I think we as academics, our role is to exactly be that critical voice. Because I see quite a few people also in my community that really jump on the hype train and just do something with AI and its innovation and so on. So I think our role is also to be a bit critical. Not to jump on the ivory tower or climb on the ivory tower and just ignore what's happening in practice, but to be a critical voice and to point to empirical evidence and not just somebody has written a blog post and now that's true. Okay, so much for the ranting. Now maybe back to Agentic AI Assistants. And on a very high level, as I mentioned, I'm trying to reach a broader audience here. Just if you think about it as a black box, a prompt goes in, a response comes out. And if we talk about large language models, natural language prompts, natural language responses. One thing I wanted to briefly mention is that like tools such as ChatGPT, they do a lot of prompt pre-processing. So please don't assume that the thing you type in is actually what the model sees in the end. So that's something people underestimate. And that's also a reason why the whole prompt engineering discussion is a bit tricky if you talk about tools, because it's not the verbatim prompt that is sent to the model in the end. And they also do a lot of post-processing. But in the end, like, think about it as a black box. And the point is, context matters a lot. Like, of course, it also matters like what the training data was of the model, but once you have a model that you want to evaluate, use, it depends a lot of what you give in. And the prompt is basically more than just the instruction, do this and that. You usually need to provide additional context, examples, or if you have a closed source code base, you also need to add code examples to that prompt. And that really matters, like what you put in, because otherwise it's garbage in, garbage out. And basically, besides this black box, what the agentic tools added is that you have an agent loop, that basically the tool runs in a loop, always inspects the context, then chooses the next thing to do, executes that, observes what the output is, and then decides on the next action. And usually the choosing is choosing to call a tool, for example. Okay, I need to know maybe what the content of these files is, or of that test for that production code, and then it can just call a command line tool to retrieve that content, and then basically it observes the tool output and then decides which other tools to call, or deciding that it's now done in the loop. So that's basically how the agents work on a very high level of abstraction. And the point is there's so much like supporting infrastructure to do that. You need an infrastructure to allow the models to call tools. You need infrastructure to basically keep memory across sessions. You need to think about permissions. Like if the tool call is remove whatever folder on my directory, I want to check that before the model actually executes the action. And the point is that I want to make is that model innovation is still super important, of course, and the performance also depends on the models you are using. But all that on the right-hand side, that's basically software systems engineering, thinking about how the agent loop works, which context you provide, and how. And that's actually one of the reasons why Claude Code kicked off. It's not just the Anthropic models, it's also the harness, the agent harness they built, and what it does. And since they leaked their source code, you can now also look at what they're doing. It's actually not that complicated to write a good agent, but it was an innovation. It was a software innovation that really kicked off also the adoption in software engineering. And just to make it a bit more concrete, how this tool calling works. So basically, what happens is that you, in your system prompt, you tell the model, these are the tools that are available. To call the find tool or the cat tool or the web search tool or whatever, you need to use, in that case, a specific XML tag where you pass also the parameters for the tool, and then that's part of the model output in the end. And then the agent harness, so the deterministic part of your tool, then looks for these patterns, for these tags, validates whether that's a valid tool call, and then checks is it allowed to run that tool or not, then asks the users or executes it in a sandbox and all that, and then it actually runs the tool, and then the output of the tool is then again processed and then fed into the next iteration, into the next prompt of the model. And the point here is that the model plays a huge role because it steers the whole loop and everything, but there's a lot of deterministic components. And that's exactly one of the reasons why it works so well, because you can combine the power of LLMs, the non-determinism that they have, with deterministic tools where you can also feed in signals such as how's my test coverage doing and whatever, does the code compile and all that. You can feed that into the loop and you use deterministic components to also verify part of the process. And that's a software engineering discussion more than an AI discussion. So that's my TLDR for that part, basically, that in software engineering, at least a lot of the discussion moved from model innovation to systems innovation, despite the tool vendors still doing a lot of marketing about their models. But actually, a lot of the performance gains we see is due to tool design more than model innovation. Now that we reached a certain level of performance. Now for the last part, the last minutes, I want to briefly talk about the empirical evidence part. And one thing that usually comes up is benchmarking. Benchmarking in AI tools for software engineering. So there are tons of benchmarks for other disciplines. I'm talking about software engineering. And I mean, with each model release, they report how great the model performed on a certain benchmark. And so it's hugely important for marketing purposes. The thing is, most benchmarks, or at least all of them that they usually use in marketing, are open benchmarks. I mean, they are open out there in the open. The models are closed, so we don't really, like, even if it's open weight, we don't know, usually we don't know the pipeline, the training data, nothing. So you have the situation that it's closed models, open benchmarks. And there's benchmark contamination, for example, because usually the benchmarks are based on open source projects. And even if you try to exclude the actual benchmark in your training pipeline, it can still happen that benchmark data leaks into your training, and then basically you have an open book exam for the benchmark in the end. And another thing, and that's something I also care about, is that these benchmarks and in the design, they don't really talk about construct validity. Like, what construct are they trying to measure with their benchmark? How do they operationalize it, and does that fit? And we will look at an example to make that a bit clearer. There are tons of papers discussing this, benchmark contamination, how difficult it is to have leaderboards about AI models, and so on. And I want to look at a very simple benchmark that has been around for a long time and is not that much used and reported anymore, but it's still a nice example because it's quite simple to show you how these benchmarks look like. And human eval basically consists of a prompt. The prompt is a Python function header, and then a docstring comment that explains what the function is supposed to do, and some examples of what the output should be. So palindrome, I guess most of you know what it is, a string that you can read in both directions. And this is one of the tasks in that benchmark. They also contain a canonical solution, but it's actually not part of the benchmark, really. It's just for validation there. So the benchmark is basically that prompt and a set of assertions. And then basically the benchmark is the model generates code based on the prompt, and then the tests are executed, and if all the tests pass, then thumbs up, the model achieved that task. And human eval is also interesting because, as far as I know, I think it's one of the first papers that used pass at k as a metric. And pass at k basically just means how likely it is, like pass at 1 would be how likely is it that the model on the first attempt solves the task. And pass at 10 would be like within 10 attempts, how likely is it that the model achieved to at least solve it once, the task. So that's the metric they are using. And basically, in summary, like pass at k estimates the probability that at least one of k generated candidate solutions for a fixed task passes the benchmark tests. So that's what pass at k measures. And then that's an operationalization. Like, that's a metric that you measure. You have a set of tasks, and that metric together with the task you provide is something you measure. It's an operationalization, or should be, of an abstract construct. And if you look at the marketing of Anthropic a couple of years back, they said, okay, and like our new model is so great in terms of coding proficiency, and they refer to human eval. So coding proficiency versus just Python, it's just pure functions, no modules, no existing code base, no debugging, just functional correctness, safety, security, readability are not relevant. And then actually that's when I would climb up the ivory tower and say, what the fuck, I mean, you see that gap, right? It's not just me. That's a very specific thing that you measure. And in the marketing, you just say coding proficiency. Like, our model is so great at coding proficiency. But that's happening for the newer benchmarks as well, not just for the old simple ones. And there's also papers showing that actually quite a few of the canonical solutions were incorrect in the benchmark. Then on average, it's just 10 assertions they use. And can you really judge whether a solution is correct based on just 10 test cases? And actually, Google had an interesting paper where they discussed how difficult it is to prevent benchmark contamination for human eval, and how quickly the performance jumps if the model has seen part of the benchmark in the training data. And actually, newer benchmarks, as I mentioned, have the same problems. So it's basically, if you see these kinds of benchmarks, keep in mind the benchmarks are open. We have to trust the model vendors that basically they have removed the benchmark from the training data, but we just don't know. I mean, there's no authority that has basically a closed benchmark that people trust and say, okay, give me the models, I run the benchmarks, and you have to trust that I have internal data that I use that the model has never seen, and then you have an accurate benchmark maybe in the end. There is no, at least as far as I know, no organization that has the authority to have such a benchmark. Okay, and with that, basically we are through the 4 points that I tried to convey very quickly. I hope I did an okay-ish job in conveying that message. And actually, like benchmarks and constructs and coding proficiency, that's very broad. But the problem is, at least for software engineering and AI, we don't even know the simple things yet. So I mentioned that on the right-hand side, there's a lot of systems innovation happening, a lot of things that vendors do. But this also means there's a lot of degrees of freedom. Like, how exactly do I do the context engineering? How exactly do I implement the agent loop? Which tools do I offer and all that? And then, I mean, there are a lot of claims of what works and what doesn't, but we just don't know. I mean, tons of degrees of freedom, not that many empirical studies that look into it. And what we do, and that's basically my conclusion, we try to look for very simple, isolated aspects to study to somehow work towards an understanding. For example, how can we use LLMs for classification tasks? I won't talk about flaky tests and what that means, but basically it's a very specific classification task. And does it make sense what research is doing? And also do LLMs work in that classification task context? But also very broadly, how do developers configure these agentic tools and try to use certain knobs to change stuff? And does it actually help or not? And we don't even have a good understanding of what all these knobs are out there that you can tune. We work towards studies that try to assess the impact of certain ways of doing context engineering on downstream performance, but also efficiency. Like, do these context files that you nowadays can provide to AI agents actually decrease token consumption, for example? Do they actually help? Do they fulfill the promise of the tool vendors? That's one experiment. Or another one, do models tend to reinvent the wheel, like rewriting a functionality that should have been reused from a library? Do they have that tendency? Yes, no, and if they do, how can we maybe avoid that? But also on the user side, what are misconceptions that developers and other users have about the capabilities of AI tools, what they can or can't do? And finally, also like along the lines of criticizing a bit the marketing, tool vendors often say, we did this and that to increase developers' trust in the tool so that adoption rises. And we try to counter that a bit with like questioning, is it a good thing always? Because there's over-trust, under-trust, calibrated trust. And also in the software engineering research, these discussions that have been out there in other disciplines for like 10, 15, 20 years, they are not really reflected in the software engineering discourse. So it's many different directions, and it's just like a subset of the things we are exploring. And this is what I mean by the simple things, the very narrow questions, even that we don't know a lot of things. And the field is moving so fast, and we try to somehow keep up, but also find the distance to work on things that are still valid in half a year or a year and not depend on individual model releases. Yeah, and I'm happy to continue working along those lines here in Heidelberg. And yeah, I would just like to see academia playing a bit more the critical role and taking a step back and basically also slowing down deliberately, because we can. I mean, in companies, it's different. You have different goals, you have stakeholders, but we can have that distance and slow down a bit, and maybe we should do that more often. And with that, we can take a few questions, I guess. Yes, thank you.